So we have been talking about fractions. First, we looked at how to name fractions, whether it was naming fractions based on a shape or naming fractions based on a number line. And then we talked about equivalent fractions, which was showing fractions that were equal to each other based on the area that they covered, not based on how many equal parts they were divided into, but the area that was being talked about. So today we're going to also be comparing fractions, but we're going to be looking at comparing fractions where we see that they're not just equal to each other, but if one of them is greater than the other one is less than. And we'll be using those comparison symbols that you've used for regular numbers in the past. And so we're only going to be looking at a certain kind of fraction today, and it's going to be fractions that have the same denominator. When you have the same denominator, then that means that you have the same number of equal pieces in each one of those, because remember, when we're comparing, we are comparing something that has the same whole thing, the same size thing. So if they are divided up into the same number of equal pieces, then those equal pieces are always going to be the same for each of the things we're comparing. So we're going to look at that more, and maybe that will make more sense as we talk about it. So here on our first example, it says Maria and Evan are both jogging a mile. Maria has jogged 7/8 of a mile and Evan has jogged 3/8 of a mile. Show how far each has jogged, and it says to use any model you choose. Who jogged farther, and how do we know this? So the way that we're going to look at it right now is we're just going to take our rectangle that they give us right here, our shape, and we're going to divide it up into a fraction. Notice how the two shapes are the exact same size, which is what we need to do if we're going to be comparing the fractions. This one is 7/8, this one is 3/8. So like I said before, they have the same denominator, which means they're going to be divided into 8 pieces. More importantly, 8 equal parts. Talked about to always go back and count when you finish. 1, 2, 3, 4, 5, 6, 7, 8. So we now have that one divided into 8 equal parts. And since the denominator for Evan was also 8, then we will also be dividing it into 8 equal parts. And then we've said that our numerator always tells how many of those equal parts we're doing something with. Well, in this case for Maria, we're doing something with 7 of them. So we would be shading in 7 of these. And down here underneath for Evan, it says 3/8. So we're going to shade in 3 of them. And looking at this, when it says who jogged farther and how do you know? Well, I'm going to be able to know who jogged farther because I can look at my model right here and easily see that more has been shaded in for Maria than has been shaded in for Evan. And so since all those little parts are the same size, I really don't have to have the picture. And here's why. Because if I know they're all the same size because they all have the same denominator, then I should know that, well, it just depends on how many of them I have. Right here, my numerator says I have 7 of them. And over here, my numerator says I have 3. So since they're all broken up into eighths, I can look and see, okay, if I look and I think they're all the same size, equal parts, then of course having 7 of them is going to be greater than having only 3 of them. So that's what we are going to be looking at. Having 7 of something is greater than only having 3 of the same something. So our denominators are not always going to be eighths, but they're going to be the same as each other. There it goes. Didn't want to change back.
How can you compare fractions with the same denominator? Think about this question during the lesson. Two banners with positive messages are the same size. One banner is 4/6 yellow, and the other banner is 2/6 yellow. Which is greater, 4/6 or 2/6?
So looking at these banners right here, it says that they are the same size. That is very important. Again, we cannot compare our fractions if our whole is not the same size. It says that one banner is 4/6 yellow, the other banner is 3/6 yellow, and it's wanting to know which is greater. Well, we need to be able to see what these sixths really are. So we're going to come over and we're going to divide both of these banners into our 6 equal parts. And now that I have these 6 equal parts drawn on here, I can see that yes, it told me that 4 of them, okay, is going to be yellow. So 1, 2, 3, 4 of those 6 equal parts. So 4/6 is yellow. Over here it says 2 in our numerator, which means we're talking about 2 of our parts. I know we have 6 equal parts because my denominator has a 6. So looking at both of these banners, they have both been broken up into 6 equal parts. Since each banner is the same size, then I know that those sixths that we see in both of these are going to be the same size. So I can tell, like I said, right there.
Remember, comparisons are valid or true only if they refer to the same sized whole. How are 4/6 and 2/6 the same?
Well, again, that goes back to how are they the same? Well, because they would be broken into 6 equal parts. Because when I see that sixth, that's what it tells me. So all of their parts are equal to each other, equal in the same size of area that each one of those would be. And you saw how I just had it drawn on there earlier, showing us how it would be in those 6 different parts. So that is why those two fractions are the same, is because their denominator is the same.
Both have the same denominator, or the same total number of equal parts of the whole.
The denominator is the number down under the numerator.
How are 4/6 and 2/6 different?
So if they're the same, because they had the same denominator, and having the same denominator again means that they have the same number of equal parts. Our numerator tells us how many parts we're actually looking at. So since our numerators are different and I see a 4 and a 2, the 4 in the first banner is telling me that 4 of those parts are yellow. The 2 in the second banner is telling me that I have 2 of those parts that are shaded yellow. So that is giving us the number of parts that we have. So why that we're speaking about. So while they have the same number of equal parts, we're talking about a different amount of each one. So they are different because our numerators are different.
Both have different numerators, or different equal parts that are described.
So it wants us to drag these 1/6 strips over to make a row that shows 4/6, and then it wants us to drag 1/6 strips again to make a row that has 2/6. So I look and I see 1, 2, 3, and 4. And on the bottom one, it wanted me to do 2/6. So I can look right here and see that I have a whole that was divided up into 6 parts here, and it could have been divided up into 6 parts here. All of those are the same whole. I am only talking about 4 of those 6 right here, only talking about 2 of them right here, and it's easy to see that having 4 of them is greater than having 2 of them. I am able to compare those because they have the same number of parts, but they're equal parts because they're equal wholes.
Use fraction strips to reason about the sizes of these two fractions. 4/6 is 4 of the unit fraction 1/6. 2/6 is 2 of the unit fraction 1/6. So 4/6 is greater than 2/6. Record the comparison using symbols or words. What is the missing symbol?
So
Select your answer.
These are the symbols that you have seen before. We have our less than, greater than, and equal to. I read them that way because if I'm reading, like reading across, doing a sentence, I come to this smaller n first. So that tells me I say less than. If I'm looking across like I'm reading and I come to the larger n first, then that's going to be greater than. So over here, knowing that I have 6, that my pieces are divided up into 6. My whole things are divided up into 6 equal parts. So those are 6. Having 4 of them is going to be greater than having just 2 of them. Because they are the same size, all I have to do is to see which one I have more of.
4/6 is greater than 2/6. If two fractions have the same denominator, the fraction with the greater numerator is the greater fraction. Now you know how you can compare fractions with the same denominator.
So we're going to be practicing comparing these fractions with the same denominator. Again, the denominators tell how many equal parts the whole is divided into. If we are taking the same size whole and dividing them into the same number of equal pieces, that means that all those pieces of both things are going to be the same size. So we are having to look at how many of those pieces we have. Since the pieces are all the same size, having more pieces is greater than having less pieces. So we're going to be practicing these using our fraction strips. We will see pictures and other things to help us to be able to understand how to compare them without anything but just seeing our fractions by knowing what our numerators and denominators mean in each of our problems.